everyone, welcome to the Ergo blockchain crash course, a quick and dirty edition. My name is Luca, I'm a developer at ErgoPad. In this video series, we're going to go over the basic concepts of eUTXO and the Ergo blockchain. We're going to learn the basics of the Ergo script language, and learn about design considerations and ethics. So this is aimed at if you're a layman interested in blockchain in general, or you're a developer interested in Ergo but don't know where to start, or if you're a miner interested in gaining a deeper understanding of the blockchain that you have invested a lot of money into and time. And also serve as a jumping off point where you can go dive deeper into other areas that you might be interested in. So we're going to cover a lot of different topics in this series. So the general course outline for each of the videos is the eUTXO model review, then the anatomy of Ergo blockchain, then the Ergo script development fundamentals, and finally we'll go over just a few examples. This is the eUTXO model review section. So in this video, we're going to cover the eUTXO model and what it is, and just answer some basic questions. So what does eUTXO stand for? Well, it literally stands for the extended unspent transaction output. So what does that mean? Well, we have to answer just a few more questions. What is a transaction? What is an output? What does unspent mean? And then what makes it extended? So first off, we'll start off, what is a transaction? So we need a conceptual model and think of a graph where each node in the graph is connected by edges. Each edge has some sense of direction. So you go from one node to the next, and you can't go backwards to a previous transaction because then you'd have cycles or loops. So the graph has to be acyclic. And then we have the graph itself, the nodes and the edges. And then along each edge, we have something called a flow. And you can think of that just as the information that goes from one node to the next, flowing along edges. So, and then a transaction is then a node in the graph. And you can think of the transaction as some state transition operation that takes the inputs edges and then brings them to another state called the output edges. So what is an output? So just like in that conceptual model of the graph, the output is just the output edges of the transaction. So in the context of eUTXO, what the output part just means that it's an output of a transaction. So what does unspent mean? So each input edge into a transaction was previously an output from a previous transaction. Before the inputs can be spent and used in a transaction, they were unspent outputs from a previous transaction. And finally, what makes it extended? So if the eUTXO model wasn't extended, we would just call that the UTXO model. And in this model, each edge contains the only data that can be on the edge is the base currency of the blockchain. So in Bitcoin, for example, that would just be like the Bitcoin value. But in Ergo, since it's the extended UTXO model, this data doesn't have to just be the base currency. It can be some arbitrary data that we want. And when we use that input in a transaction with that arbitrary data, we are able to use that data to do something. So, and this is an informal mathematical definition of what UTXO is. So you can just think of an output as a pair of values, a tuple of three parameters, a validator, a value, and a datum. And an output can be spent or used as an input if the validator function, whose parameters are the value, the datum, the redeemer, and the transaction context, if all of that evaluates to true. So transaction is the transaction information, and the redeemer is the person who is able to sign the transaction and spend the box. So in Ergo, we call it UTXO a box. And then just to show the parallels between this sort of description within Ergo with the informal mathematical definition, we see that a box in Ergo can contain arbitrary data, so that's like the datum. The box can contain a script or a contract, so that's the validator. A box must contain a minimum amount of the base currency, so that's the value, but the value could also be more than the minimum amount. And within a script or a contract, we have access to the transaction context. So that's like the transaction as a parameter in the validator function. And then in order for the inputs to be spent, the transaction must be signed, so we have a redeemer. And then we can think of the boxes themselves as the actual edges in the conceptual model of the graph that we had before. So each transaction which was a node in the graph, had input edges, and we can think of the input edges as these boxes, and then the output edges as new boxes that were created. And that's it for this video. Hopefully, you have a better understanding of what eUTXO is and what it stands for. And if you're interested in the next sections, please continue watching. Thank you.